Okay. Um, Today we're talking about complex research designs. Um, I'm not sure why they put it here in chapter 8, but we're going to talk about most of what we're actually doing in your research because you have a lot of factors that are categories, age, education. These are categories, and the reason they're categories is because you don't manipulate them. This is, if you're 55 years old, I can't say, well, act like a 26-year-old. That's not going to work. Um, and same way with gender. I can't say, well, you're male. Can you be a female? Because I need one more male or one more female. Yeah, you can't do that. It just doesn't work that way. So we're going to talk about complex research designs. Um, and this is probably what your research will look like. Uh, don't get too involved in it. Don't uh, worry about it because we you can always make it work. One of the interesting things is that mathematicians really don't like social science statistics because there are no absolutes. So in mathematics, one is always just that many, and two is always just that many. But in psychology, when you're dealing with gender, there are no absolutes, and you can recognize as many genders as you like. Normally, you just will recognize male and female, but I mean, you could recognize bisexual or sexual orientation as part of the gender or however they identify themselves as no gender at all or whatever. I mean, you can do that. And education, it's the same way. It's you can put a number to it that represents how many years you've had education. Anyway, okay, let's go ahead and get started. Don't worry too much about this chapter. I just want you to understand the concepts. We're going to talk about the last thing we're going to talk about is the most important thing in the chapter, which is regression analysis, and it's how you will figure out what the impact of the different independent variables are on the dependent variable. And it's a way of doing statistics, but you have to do statistics. You have to be real. You have to be real flexible in order to understand what's going on. Mathematicians don't like regression analysis because you're comparing. Sometimes you're comparing categories with numbers, and it feels like it doesn't fit. It's like saying on a scale of 1 to 10, how much depression do you have, or how much pain do you have? My doctor and I talk about this from time to time. I have fairly high pain tolerance, so yeah, it, it may be fairly excruciating, but I'm not going to admit it, or you know show me what a 10 is, okay? Here, punch me in the face and show me what a 10 is. Anyway, let's go ahead and get started. Chapter 8. We're on chapter 8. There we go. Don't ask me why I picked this PowerPoint presentation. I have no idea. Often a researcher wants to know how an independent variable affects several distinct dependent variables. Researcher Susan Nasco was interested in how different odors affect people's behavior. She conducted an experiment in which the independent variable was whether participants were tested in a room with no odor or in one scented with lemon, lavender, or dimethyl sulfide, which is a cabbage-like smell. Um, it smells like it smells like old cabbage, is what it smells like. Although she was primarily interested old cooked cabbage is what it smells like. Although she was primarily interested in how the odors affected people's creativity, she was also curious about how they affected people's moods and perceived health, and it was a simple enough matter to measure these dependent variables too. Although she found that creativity was unaffected by the ambient odors, ambient means what the smell is in the room. She found that people's moods were lower in the dimethyl sulfide condition, where it smelled like there was, rotting cabbage, cooked cabbage sitting in the corner somewhere, and that their perceived health was greater in the lemon condition, and that may be why they put lemon in cleaner and all the cleaners. Well, for one thing, it cleans, and for another thing, it puts a pleasant smell that people enjoy, the citrusy smell. It's kind of like juggling. When an experiment includes multiple dependent variables, there is a possibility of carryover effects. For example, it is possible that measuring participants' moods before measuring their perceived health could affect their perceived health, or that measuring their perceived health before their moods could affect their moods. So the order in which multiple dependent variables are measured becomes an issue. One approach is to measure them in the same order for all participants, usually with the most important one first so that it cannot be affected by measuring the others. Another approach is to counterbalance or systematically vary the odors in which the dependent variables are measured. When the independent variable is a construct that can only be manipulated indirectly, such as emotions and other internal states, an additional measure of the independent variable is often included as a manipulation check. This is done to confirm that the independent variable was, in fact, successfully manipulated. Manipulation checks become especially important when the manipulation of the independent variable turns out to have no effect on the dependent variable. And this is where we get into some really strange research. I'm going to make you depressed. And the way I'm going to make you depressed is to tell you a story. Well, okay, so you think this is a depressing story. To me, it may not be depressing at all. You may not be changing my mood at all. This is the part that drives me crazy about some social science research. They try to manipulate your thoughts or your emotions, and not everybody has the same reaction to a story about a lion's eating a baby deer or whatever. Some people go, okay, well, that's supposed to make you depressed. Well, maybe it makes it makes the researcher depressed, but it may not make anybody else depressed, or it might affect a select group of individuals, but not other individuals. I mean, that's really what we're talking about. In the example in your textbook manipulating emotions, I read it and I said, this isn't very good research. I'm not going to talk about this because to me, it didn't make any sense. But then again, I've seen things that other people haven't seen. For example, if you expose participants to happy or sad movie music intended to put them in a happy or sad mood, but you found that this had no effect on the number of happy or sad childhood events they recalled, this could be because being in a happy or sad mood has no effect on memories for childhood events. But it could also be that the music was ineffective at putting participants in happy or sad moods. That's the point I was just trying to make. A manipulation check, in this case, a measure of the participants' moods, would help resolve this uncertainty. If it showed you that, if it showed that you had successfully manipulated participants' moods, then it would appear that there is indeed no effective mood on memory for childhood events. But if it showed that you did not successfully manipulate participants' moods, then it would appear that you need a more effective manipulation to answer your research question. And this is part of the problem. You have researchers that are doing research who need to get that research done, and they don't always check to see if what they said is happening is actually happening. think this is Kristen Bell. I don't know. Kind of looks like her. Another common approach to including multiple dependent variables is to operationally define and measure the same construct or closely related ones in different ways. For example, if a researcher conducts an experiment on the effect of daily exercise on stress, the dependent variable stress is a construct that can be operationally defined in different ways. For this reason, the researcher might have participants complete the paper and pencil perceived stress scale and measure their levels of stress hormone cortisol. This is an example of the use of converging operations. If the researcher finds that the different measures are affected by exercise in the same way, then they can be confident in the conclusion that exercise affects the more general construct of stress. When multiple dependent variables are different measures of the same construct, especially if they are measured on the same scale, researchers have the option of combining them into a single measure of that construct. When researchers combine dependent variables in this way, they're treating them collectively as a multiple response measure of a single construct. The advantage of this is that multiple response measures are generally more reliable than single response measures. However, it is important to make sure that the individual dependent variable are correlated with each other by computing an internal consistency measure such as Cronbach's alpha. Cronbach's alpha. Just as it is common for studies in psychology to include multiple dependent variables, it is also common for them to include multiple independent variables. Just as including multiple dependent variables in the same experiment allows one to answer more research questions, so too does including multiple independent variables in the same experiment. And there you go. Oh, you've got blue dots, green dots, red dots, and black dots. Okay, and they're all over the place. Including multiple independent variables allows the researcher to answer questions about whether the effect of one independent variable depends on the level of another. This is referred to as interaction between the independent variables. Interaction. Schnall and her colleagues observed an interaction between disgust and private body consciousness because the effect of disgust depended on whether participants were high or low in private body consciousness. As we will see, interactions are often among the most interesting results in psychological research. I can't remember why I put that GIF in there. I like this one. The most common approach to including multiple independent variables in an experiment is the factorial design. In a factorial design, each level of one independent variable, which can also be called a factor, is combined with each level of the others to produce all possible combinations. Each combination then becomes a condition in the experiment. For example, you could have an experiment that looked at the effect of cell phone use, yes versus no, and time of day, day versus night, on driving performance. Here she is texting. I guess she's swiping and not watching the road, even though she's driving. The factorial design table is a table used to represent factorial design. I just figured out how dumb that statement is. The factorial design table is a table used to represent factorial design. The rows represent the levels of one independent variable, the columns represent the levels of a second independent variable, and each cell represents a condition. This particular design is a 2 by 2 factorial design because it combines two variables, each of which has two levels. If one of the independent variables had a third level, for example, using a handheld cell phone, using hands-free cell phones, and not using a cell phone, then it would be a 3 by by 2 factorial design, and there would be 6 distinct conditions, and there would also be 6 boxes. Notice that the number of possible conditions is the product of the numbers of levels. 2 by 2 factorial design has 4 conditions, 3 by 2 factorial design has 6 conditions, a 4 by 5 factorial design would have 20 conditions, and so on. Oh, I didn't put a picture. In a simple within subjects design, each participant is tested in all conditions. In a factorial experiment, the decision to take the between subjects or within subjects approach must be made separately for each independent variable. In a between subjects factorial design, all of the independent variables are manipulated between subjects. There you go. That's how many is that? 8. A 4 by 2. In a within subjects factorial design, all of the independent variables are manipulated within subjects. All participants could be tested both while using a cell phone and while not using a cell phone, and both during the day and during the night. This would mean that each participant was tested in all 4 conditions. The between subjects design is conceptually simpler. It avoids carryover effects and minimizes the time and effort for each participant. The within subjects design is more efficient for the researcher, of course, and controls extraneous participant variables. It is possible to manipulate one independent variable between subjects and another within subjects. This is called a mixed factorial. For example, a researcher might choose to treat cell phone use as a within subjects factor by testing the same participants both with using a cell phone and while not using a cell phone, while counterbalancing the order of these 2 conditions. But they might choose to treat time of day as a between subjects factor by testing each participant either during the day or during the night, perhaps because this only requires them to come in for testing once. Thus, each participant in this mixed design would be tested in 2 of the 4 conditions. We have animals, and I always close the doors. I always close the doors when I'm trying to record. But I leave one door cracked open because there's food in here for the cats, and they'll sometimes jump in. Well, there's nothing more interesting than a closed door to a dog and a cat. So I get a revolving door of animals coming in to see what I'm doing. You wouldn't think that cats and dogs would care about me talking, would you? But I guess they do. In many factorial designs, one of the independent variables is a non-manipulated independent variable. The researchers measure it but do not manipulate it. An example is a study by Hallie Brown and colleagues in which participants were exposed to several words they were later asked to recall. The manipulated independent variable was a type of word. Some were negative health-related words, tumor, coronary, and others were not health-related, election, geometry. The manipulated independent variable was whether participants were high or low in hypochondriasis, excessive concern with ordinary bodily symptoms, which we don't call hypochondriasis anymore. We call it dysmorphic, no, that's not right, dissociative health identity or something. The result of this study was that the participants high in hypochondriasis were better than those low in hypochondriasis at recalling the health-related words, but they were no better at recalling the non-health-related words. And these are examples of non-manipulated variables. You can't change people's age, you can't change their sex, you can't change their ethnicity, you can't change their learning style, you can't change their socioeconomic status or their parental educational level or their family environment, their preschool attendance, or their type of school. Non-manipulated independent variables are usually participant variables, private body consciousness, hypochondriasis, self-esteem, and so on. and as such, they are by definition between subject factors. For example, people are either low in hypochondriasis or high in hypochondriasis. They cannot be tested in both of these conditions. Such studies are generally considered to be experiments as long as at least one independent variable is manipulated. Regardless of how many non manipulated independent variables are included, it is important to remember that causal conclusions can only be drawn about the manipulated independent variables. My dog is underneath the desk, right under my feet. I closed the door. What's wrong with me? The results of factorial experiments with two independent variables can be graphed by representing one independent variable on the x-axis and representing the other by using different kinds of bars or lines. The y-axis is always reserved for the dependent variable. This is the y-axis, and this is the x-axis. The top panel shows the results of a 2x2 design. Time of day, day versus night, is represented by different locations on the x-axis, and cell phone use, no versus yes, is represented by different colored bars. The bottom panel shows the results of a 4x4 design, a 4x2 design, in which one of the variables is quantitative. Actually, there's only two there. Oh, there's four. This variable is represented along the x-axis, and the other variable, psychotherapy type, is represented by differently formatted lines. This is a line graph rather than a bar graph because the variable on the x-axis is quantitative with a small number of distinct levels. In factorial designs, there are two kinds of results that are of interest: main effects and interaction effects, which are also called interjections. Interactions. Interactions. The main effect in a factorial design is a statistical relationship between one independent variable and a dependent variable, averaging across the levels of the other independent variable. Thus, there is one main effect to consider for each independent variable in the study. There is an interaction effect, or just interaction, when the effect of one independent variable depends on the level of another. Although this might seem complicated, you probably have an intuitive understanding of interactions already. It is no surprise to hear that the effect of receiving psychotherapy is stronger among people who are highly motivated to change than among people who are not motivated to change. This is an interaction because the effect of one independent variable, whether or not one receives psychotherapy, depends on the level of another, motivation to change. The effect of one independent variable can depend on the level of the other in different ways. One independent variable may have an effect on both levels of a second independent variable, but the effects can be in opposite directions. This is called a crossover interaction. In a crossover interaction, the two lines literally cross over each other. And this is what we see here, and this is what we see here. Oh, I'm sorry. Here. Sorry. Here. And what I just showed you. Factorial designs can include only non-manipulated independent variables, in which case they are no longer experiments but correlational studies. A researcher measures both the moods and self-esteem of several participants, categorizing them as having either a positive or negative mood and as being either high or low in self-esteem, along with their willingness to have unprotected sexual intercourse. This can be conceptualized as a 2x2 factorial design with mood, positive versus negative, and self-esteem, high versus low, as between subjects factors. Willingness to have unprotected sex is the dependent variable. This design can be represented in a factorial design table and the results in a bar graph of the sort that we have already seen. The researcher would consider the main effect of sex, the main effect of self-esteem, and the interaction between these two independent variables. And of course, being the medical person that I am, I'm showing you the side effects of unprotected sex, like HIV, syphilis, genital herpes, gonorrhea, hepatitis A, B, or C, and a high chance of getting pregnant. Getting, I'm not sure what that word is. Most complex correlational research does not fit neatly into a factorial design. Instead, it involves measuring several variables, often both categorical and quantitative, and then assessing the statistical relationship among them. This approach is often used to assess the validity of new psychological measures. A correlation matrix shows the correlation, Pearson's R, between every possible pair of variables in the study. This is Pearson's R, of course. When researchers study relationships among a large number of conceptually similar variables, they often use a complex statistical technique called factor analysis. In essence, factor analysis organizes the variables into a smaller number of clusters such that they are strongly correlated within each cluster but weakly correlated between clusters. Each cluster is then interpreted as multiple measures of the same underlying construct. These underlying constructs are also called factors. Sorry, I needed a drink. Factors are not categories. Factor analysis does not tell us that people are either extroverted or conscientious, or that they are either reflective and complex music or intense rebellious music. Factors are constructs that operate independently of each other. Factor analysis reveals only the underlying structure of the variables. It is up to the researchers to interpret and label the factors and to explain the origin of that particular factor structure. An important use of complex correlational research is to explore possible causal relationships among variables. This might seem surprising, given that correlation does not imply causation. It is true that correlational research cannot unambiguously establish that one variable causes another. Complex correlational research, however, can often be used to rule out other plausible interpretations. When it's hot outside, ice cream sales go up, as do sunburns. Complex correlational research can be used to rule out other plausible interpretations. The primary way of doing this is through the statistical control of potential third variables. Instead of controlling these variables by random assignment or by holding them constant as in an experiment, the researchers measure them and include them in the statistical analysis. Many studies of this type use a statistical technique called multiple regression. This involves measuring several independent variables, all of which are possible causes of a single dependent variable. This result of a multiple regression analysis is an equation that expresses the dependent variable as an additive combination of the independent variables. The results indicate how much the dependent variable changes for each one unit change in the independent variable. And that's multiple regression. This is really kind of interesting. One summer, my son's a mathematician. And one summer we were going to hire him to teach statistics for social sciences. And so I gave him my book. And of course he just shot right through the thing and he went, I can't teach this. None of these numbers are absolute. I talked to you about it before. and so I had to teach the class. was but I taught the class under his name, so he got the paycheck. uh, anyway, not important, I guess. The advantage of multiple regression is that it can show whether an independent variable makes a contribution to a dependent variable over and above the contributions made by other independent variables. Don't ask me why. This is the picture that I chose. And that is the end of the lecture. Like I said, don't worry too much. All I need you to understand is that this is the way that we put social science research together. We use groups of independent variables. Some of them are categorical, some of them are numerical, and this is the way you have to do uh, social science research. It's raw statisticians, mathematicians don't like it, but I mean, it's the only way that we can compare one group with another group, um, trying to determine what causes depression. You need all these speculations. This is a good way of speculating one thing or another. Let me get rid of that. There we go. One thing or another. So there you go. That's just what I want you to know. I need you to understand that regression analysis, while it works for social scientists because we're talking about speculation, my eyebrows messed up, doesn't really work that well for mathematicians who cringe every time we talk about this stuff. But that's okay. I'll talk to you again next week. Next week, we're talking about surveys. I found the order of these chapters a little curious, but what can you do?